lab water waves. And I always like to do the virtual lab with you guys so that some of you who can't do these on your own, maybe you just don't have the resources or maybe you're short on time. I definitely like to cover these so that you can see them and fill them out with me. So hopefully you got the prompt to save the file, the assignment file, if anybody needs it. No, that's okay, no worries. If you need that file, I'm going to prompt you just to save it again. You can dismiss it or print it or whatever. And if you don't have time to print or you're not in a situation right now where you can print it, grab some paper and you can jot it all down and then transfer it later. So this lab, I found that some students were like, oh, so easy. And then other students were like, I don't understand. This is really hard. So I think it takes just a little bit of patience and some understanding. And so I have it set up on my desk. And so what I really need is one of those document cameras. And it like sits on a stand, kind of like those little lights that go on your nightstand or something that like you can move the neck around. But it's a camera. I really need that, but I don't have that. So you'll have to bear with my amateur skills, and I'm going to move my webcam over and hopefully prop it up so that you guys can see me doing the lab as well. And then for those of you that have already completed this, definitely I encourage you to help us out. And maybe when we get to the part where you're drawing the waves in, to help us do that. Because I think sometimes that's part of the misunderstanding there. So are you guys getting lag? I may have to turn my webcam off. But just a reminder, no, you don't even have to do that. You can just complete it and submit it. Yeah, I don't mind at all. So that was a great question. All right, so you guys can use the chat features. I hope you will throughout the session. We can, let's try this. We haven't done this in a while. So I'm going to change the webcam settings to maximum simultaneous cameras. And I'll see, hopefully it doesn't overload our system. But if you guys want to jump on webcam too, you may want to let your family know that you're on webcam. So, you know, that way, if you would like to jump on, you can click and be on webcam too. It'll pop up at the bottom. We can all say hello. But you don't have to. Some people don't like being on the camera. But just make sure your family's aware so they're not walking behind you like out of the shower or something weird. All right? So join me on webcam if you would like. And feel free, guys, chat as we go, and we will jump through and get the lab done. So the drawing part, okay, yeah. So that's a great question, Rylan. You can print this out and handwrite it. A lot of these labs, it's easier to do that, and I'll talk to you at the end on how we will upload that, because it is a little bit different. All right. So today's interaction, today's objective, we want to interact with each other. We want to definitely take a look at this lab together and make sure that we know how to do it, and we're seeing these water waves, and we want to have fun. I think labs are always fun, so let's dive into that. So the lesson today is on sound waves or waves traveling, and we're going to take a look at some water and dropping an object in and seeing those waves move through the water and kind of diagram that out a little bit and talk about this. So that's basically what the gist of this lab is. All right. So one thing that I want us to take a look at, because I think it's helpful, is understanding this image that is in the lesson. And it shows you kind of an idea of what you're going to be diagramming. So I'm going to share my screen with you guys. Let me get to that page. And let's see. Okay, hold on a second. This is, okay, share my screen. All right. Ooh, I went right to this one. Can you guys see that? I'm going to turn my webcam off just in case. Yeah, it's lagging a little. But let's take a look at these little pictures together. So I know it's really small, and you kind of have to look really close, but it's talking about like the different waves. Oh, no, that is okay, Rylan, don't worry. And we'll help you tweak up those drawings in this session. So if you look, you've got, we know a wave, and you guys might have seen that yet in the content where you've got a trough and a crest and all that. And it's a little different when they're coming out in rings. So this one shows constructive interference occurs when the crests of two waves meet. So we've got those rings coming out. Those waves are meeting, and they affect the wave shape. That's basically what this is saying. And so in the next picture, that looks almost the same as the first picture. What's the difference here? So you're showing destructive interference. This to me looks exactly the same. The difference, let's check out the red and blue where they are. Yeah, that looks exactly the same to me. So it's showing the destructive interference is in gray and the constructive interference is in yellow. So it's looking at this bar specifically, okay? And so the deal here, destructive interference occurs when the crest of one wave meets the trough of another wave. That's kind of technical. The waves cancel each other out then, and they reduce the amplitude. So maybe for taking notes on this, I would write down the difference in constructive interference and destructive interference. So destructive, the waves cancel each other out, and then the constructive is they add to one another. So you can kind of remember that in your head. Constructive, create, they add. Destructive is going to like break down, cancel. Okay? So diffraction, this is like a picture of maybe what you're going to see. Right? You've got it bouncing off an object and going outward. So diffraction occurs when a wave encounters an obstacle. And in this case, our obstacle is going to be that glass in the water. And so the waves are going to bend around it. And so that's what we're going to be seeing here. So you can see the waves, and then they hit something, and then they kind of diffract. So that's kind of cool. And then finally, water waves. Here's a picture that we're like, oh yeah, here's what we're dealing with. So water waves are surface waves. And the energy of the wave moves parallel and perpendicular. So remember, parallel is like if you were to, like look at my arm. This is how I remember parallel. Parallel is like this, right? They run, they do not cross, right? Perpendicular though, like this. So you can hopefully remember that. All right. So let's go forward and go back over here. And so when we draw those observations, here were some tips that we got out of the lesson. And I know this looks blurry for you guys, so I'm just going to kind of bullet point it. It says use labels. So when you're recording your data, kind of label what you're seeing. And then it's more useful when you can draw and like label what you're observing. And then remember the scale. So sometimes things are smaller or more complex than you can draw them. So that's okay to make them bigger. You don't have to make it really tiny. That makes it really hard. So make it bigger, it's easier. And then keep it organized. So you can also include drawings in the data table. And to do this, you have the two columns on your table. One, you write a description of what you're seeing, and then the other, you're including the drawing itself. All right? So the materials for this lab are water, glasses, plain paper, ruler, high pan. I use a larger rectangle pan. It is clear, and then 2 pennies. So making waves, while sound waves are difficult to visually observe, water waves are much easier to see. So in this activity, we're going to use the surface waves of water to observe that wave motion. We'll see the interference between 2 waves and the diffraction of waves. So we're going to see waves just hitting each other, and then we're going to see waves hitting an object and bouncing off. And so this activity simulates how sound waves behave. So it's kind of cool. All right, so when you get to this page in your assignment, you can always be tricky because I don't like those little boxes. I think they're a lot to deal with. So what I like to do is click here and just print out the instructions. And then I am like doing my lab. I don't have to have my computer, and I can, I'm pulling mine out of my notebook right now. And then I can, you know, just look at the page and follow the steps as opposed to having to come over here and click all the time. So that makes it much easier. And so from there, here's what it looks like. So we've gathered the materials, and this is where you guys are going to have to be patient with me and my videographer skills here. I'm going to see if this will stay here and what it will record. So bear with me 1 second. I'm going to get it to stay, and then you guys tell me how it looks. So here's the video, and I'm have to move it here. Can you guys see that? So the only thing that might be hard is that the waves might be kind of tricky to see. So I'm not sure how far my webcam cord will stretch. I think I'm at the end. So I'm going to try to move it closer. Backwards. There we go. And see if you guys are able to see the ripples. But I'll explain it to you just in case you can't. And I'm also going to do this. I'm going to move my lamp closer because I think when it has more light, it might really help with those waves. So that doesn't look like it made it much brighter on your end. A little bit maybe, hopefully. Okay, so you have the columns, right? Let me get that page out. And so you're putting what you see in your observations in those 3 columns, all right? So the conditions, really here it's just saying what step you're doing. So like in a well-lit area, the first thing we're doing is placing basically the setup. You've got your pan on white paper with the water. So it's just telling you the step of the lab. You can copy that from like, that's step number 2. That would be your condition. All right, so if we go into reminders, you need to print this, this is where it is. Or it's also in the Dropbox portion. But this is where we're at first, okay? And so conditions, it's saying, that's where you would put step 2. Go to the well-lit area, fill it, you know, fill the thing with 2/3 of water, you're ready to go. And then you're holding, actually it kind of combines step 2 and 3 here. So that's what you'll, and you don't have to write all of it, just basically what you did. You set it up, and you held the penny 15 centimeters, centimeters above the center of the pan. Okay, so I need to actually take my glasses out right now. I got ahead of myself. Need to put them on something dry here. Okay, so we have this pan of water, and we are taking our penny, okay, and we are holding it 15 centimeters. Found the one bench ruler that we have in our house. So 15 centimeters is here. Can you guys see that? And it's just saying drop it in and then watch the shadows on the white paper. All right, so I'm holding it here. I'm trying to get everything out of the way. All right, so could you see the water waves? I'll do it again. Okay, 15 centimeters. All right, so basically, did you guys see that? We saw what, where it hit, and then they went out. So the notes would be a description, and the observation would be your drawing. So basically, we showed, I would, even put something as simple as the rings went outward from where the penny landed. I mean, very basic. And then your drawing is going to look, if anybody wants to take the whiteboard tools and draw that, if you've already done this and you're like, oh, I'm a pro, I got it, and you want to draw that for us, awesome. Thank you so much. Exactly, that's what you're seeing. Okay? Perfect. So we've done the first block, right? The first 3 squares, the top 3. So we wrote down what we were asked to do, and then we kind of wrote in our notes, you know, we dropped the penny and the rings made a circular motion from where the penny landed, and now we're ready to go on to the next one. So it says that 4, you hold 2 pennies 10 centimeters apart, and we are going to drop those and see what happens. Oh, perfect. Thank you for adding that in the notes. Okay, so now I'm going to get 2 pennies 10 centimeters apart and 15 centimeters above. I'm going to drop. Oh, that one stuck to my hand because it was wet. Let's try it again. There we go. And I'll do it again so you guys can see. So let the water settle. All right. So this one, we kind of saw the same thing, but those waves hit each other, right? So conditions would be 2 pennies, 10 centimeters apart, dropped. Yes, it does happen really fast. I need a, slow motion. That would be awesome. So 2 pennies, 10 centimeters apart, we drop from 15 centimeters and observe the waves. So that's your condition. Basically just step 4, what we did. And then the notes, we saw basically the waves met each other, and then they kind of combined into bigger surface waves, right? So you would have just what's being drawn there, like 2 of those bumping into each other. Perfect. Yep, so we've got, it's kind of hard to add those circles. Yeah, you're just seeing 2 of the same thing. Perfect. I like it. That's a great description. Perfect. All right. So remember that that's kind of what we talked about being construction interference. So if you want to get super technical, you could write down that constructive interference occurred because those waves met, and then they created kind of, I know it's hard to tell, but so when they hit, those waves made their rings, and they kind of made big rings together going outwards. And that means they kind of combined, and that's what the constructive interference means. So that could be in your notes, and I can even type that too if y'all want me to help you out here. Let me fix my box size. Oh no, you don't have to use pennies. Dimes, nickels, marbles, whatever, those would all work. Whatever you need to drop in the water. Okay, let me type here. Okay, so here, like I said, if you want to be super technical, constructive interference occurred. We had the 2 waves met one another. All right. And then again, over here, we are just writing the basic steps of what we did. And so if you were writing, I know if you've got to draw this in, I don't know that you can type in as well, so that might be tricky. And then finally, we are going to get 6. And it's saying, okay, well, step 5 says put the 2 glasses in, and they should create a slit that is 1 centimeter wide. So this is kind of hard. We get the pennies out and dry them off. We have these 2 glasses, and they have to be 1 centimeter apart. And so mine, like, this is as close as they can get. And I'm going to turn them like this way. Does that help you guys see better? Because, and even these are not like narrow, they're all pretty much the same up and down, but that is going to help you be able to see a little better. Let me see what's in chat really quick. So, ignoring the conditions. Yeah, you would get a really good grade on this. So I'm glad that is relieving. All you have to do is fill in this part. These boxes over for conditions, just write what's in the steps. And that you can pull up from the lesson. Okay, perfect. All right. The one thing, though, I need to mention, because I do have students that do this sometimes, if you're watching this as a recording, it is not okay to take a screenshot of this and submit it. I have had students do that. So if you are watching it as a recording, make sure that you do your own page and don't just screenshot mine. That really means you did not do it, or you didn't even write. So with that, it looks like we have some lag. Are we good on sound and chat and all that? Is it lagging? Mostly good. Okay. I can see that it's kind of a mess. All right, so we've got the 2 glasses in. Our split is going to be, let's check, maybe it's roughly, I think we're pretty good there. So, awesome. The video is laggy, okay. So now it says hold 1 penny 15 centimeters above the shallow pan of water and drop it to one side of the slit. So we're dropping 1 penny and observe the ripples as it reaches the glasses and goes. We're looking at the waves going through the slit, not the penny. So I have to hold it like as close as possible. So I'm dropping it here, and I'll do this several times so you can see. So remember, we're looking at diffraction. So now we've seen these waves before going in these circles, like on the screen, but now they're going to hit these glasses, and so it's going to do something different. So let's watch. Okay, and I'll do it again. If you notice, and I don't know if you can see, I'm going to try to move it so that you guys can see above. I'll get a little closer. Well, then you can't see. Oh, this is backwards for me, so every time I move the camera, it is not in the correct way. Okay. I need a cameraman. All right, here we go. All right, so what is it doing as it is hitting these glasses? I mean, the waves, not the tank. So we're still seeing the ripples occurring. We're still seeing the same kind of thing, but then it's hitting those objects and it's going around. All right, does that make sense? Were you guys able to see that? Yeah, they bend and go around the cup, so you're exactly right. And they're smaller on the other side. Good observation. So that's what we would be writing now. And the way that maybe the best way to draw it, let me see if I can change the shape. And so if I'm going to make 2 blue circles here. And these are going to represent the glasses. Hopefully it'll let me move them. I think I have to click differently here. No, what are you doing? Okay, so I'm putting these together. So those are the glasses, right? And then now we could add the waves. So, yes, perfect. So we saw that maybe on the, right, we saw the waves continue, and then we saw them kind of bend and go around and through the slit, and then they went out and made some smaller waves. Perfect. Okay, so I know that we're getting, it's 11 o'clock now. If any of you need to, yes, that drawing is perfect. If any of you need to go, because I know you may have another session, I'm going to continue through really quickly and get to the questions. We're going to go through them pretty quickly, and I will try to type as we answer so that they're here. I know it's hard to kind of copy sometimes. So I'm going to type these in, and we'll kind of talk through. You guys let me know, and then we'll be out of here. So if you need to go, that is totally fine, and I'll post this recording. All right, so we're describing the pattern as one penny dropped into the water. So basically, we're taking from the note at the top, the very first one. We showed circular motion from where the penny landed, okay? Question 2, after 2 pennies were dropped, so we're just pulling that data, right? We are just pulling our note in the middle box. And that was, we saw the 2 waves met each other and created, whoops, typo there, combined kind of. They made a large surface wave, okay? And when describing the split, describe the initial disturbance. So that, oh, I keep forgetting this part. When using the slit, so we have the glasses in there, the shape of the initial disturbance. So that one we had a circular motion that spread out, pattern I would say that spread out like the others, but then around the glasses. And we know which is diffraction. Remember that word. Okay. And then question 4, compare the disturbance before and after the waves passed through that slit. And I think you guys noticed that these waves were smaller after. And they also, make sure, they bent around the 2 glasses, so you were seeing diffraction, they were smaller. Let me make my watch is ringing. Hold on. Okay, so waves were smaller after they hit, we'll say hit, the glasses. Basically, we know that was diffraction occurred. Okay, and then finally the last one, use this little example to explain why you can hear a noise in another room through an open door. So think about that. In another room through an open door, what would happen to those waves? So the waves are going to carry, they are going to hit the walls, the doors, and they will diffract, right? And go carry into the next room. So sound waves would bounce off walls and doors and diffract to carry into the next room. All right? So any questions on that? I know we are over the time limit. This is going to be up here if you want a screenshot or anything really quick. And then I really real quick want to show you, we're going to skip that. Obviously, you're going to go to the Dropbox for this. If you have handwritten your answers, a couple of things that you may want to know. If you already know how to do this, you're free to go. But if you have not done this before, if you wrote your answers, you can scan it in. Sometimes it scans it and it's kind of weird. But you can also take a picture, like with your phone, make sure it's over the whole page and that you, can see everything clearly, nothing's cut off. And then you will email yourself that photo. So for those of you going by, make sure that you open up that photo. You can sometimes just upload that file if it says it won't let you. Open up a Word document, paste the photo onto the Word document, kind of spread it out, make it big. If it's really tiny and turned upside down, it's hard to grade. And then save that as a PDF. So you go to File, Save As, and then under where you name it, you can change the file type to PDF, and then you're able to upload that PDF into the Dropbox with no problem. All right? So you guys have done it. Thank you so much for your participation. I'm glad we were able to get this assignment done together. And you guys have a wonderful day. And sorry about that.